Hello everyone, welcome to another video of Calculus 1. In this video, I'm going to introduce you the formal definition of a limit. You might remember that we defined the limit in section 2.2 by saying that limit x goes to c, f of x equal L if f of x magnitude of f of x minus L becomes arbitrarily 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 small when x sufficiently close to c. Uh, Now, what does that mean? That means if I show you in a graph, we have function f of x and c in here, right? C can be reached from either from negative side or positive side. That means in this interval, in this interval, you have f of x negatively here and f of x positively here, and this is where that limit L is at, right? L is at. And when x getting closer and closer to c, this distance given by fx minus L magnitude becomes smaller and smaller, right? So when you move just a little bit here, you get a small distance in between L and f of x, either positively or negatively. So mathematicians came up with a formal definition, a formal definition for this one. Uh, to represent this in more general way, they said that if uh, we can find a value epsilon, right? The value epsilon, that is positive value epsilon, right? We can find positive value epsilon, and then corresponding to that epsilon, there is a delta which is positive. I will explain what that epsilon is. If x minus c, that's the distance between that x value, arbitrary x value, and c right here, becomes less than delta, right? This delta is positive value, so this x minus c is always greater than 0 because it's a magnitude, right? Than 0. Then if we can find epsilon, that has corresponding delta which is greater than 0, then we can say that f of x minus L less than epsilon. So in layman's word, right, what does that mean? This is that distance epsilon, right? So if you can find some small distance epsilon where it, sorry, this is that distance epsilon right here. So if I show you the epsilon, epsilon is right here. Epsilon is the distance between that f of x, f of x and L, right? This epsilon. Corresponding to that, you have some delta, which is the distance between that arbitrary x and c, right? So what does that mean is you can find for any delta, for any positive value of delta or any positive value of epsilon, right? You should be able to find any delta that is positive. Okay. In that case, uh, you can write limit x goes to c, f of x equals L, right? That's the formal definition, right? The formal definition is given in formal language like this. Suppose f of x is defined for all x in an open interval containing c, but not necessarily equal to c, right? Then limit s goes to c, f of x equals L if for all epsilon greater than 0 there exists delta greater than 0 such that if x minus c magnitude greater than 0 and less than delta, then f of x minus L magnitude is less than epsilon. So what does that mean? That means again, when this distance right here, we can find a very small difference epsilon greater than 0, you should be able to find some delta in between, some delta value between x and c. For all epsilon and all delta, this is the same. So when you change delta, your epsilon changes. But you should be able to find some value for any value of epsilon, some value of delta for any value of epsilon. Let's take an example. You might understand this a little bit more in that case. So let's take this for an example, okay? Let's take this. F of x equals sine x over x, right? Now what we find is limit f of x limit x goes to 0 f of x, uh, which is equal to limit x goes to 0 1 sine x over x equal 1. So we want to prove that this limit is uh, limit exists. So how do we prove? We need to prove that for any selected value of delta, you have some selected positive value of epsilon. right? So C in this case, so what we need to find? We need to find some delta that X minus C less than delta such that uh, Ff, that is f of x minus L, then epsilon, right? Okay, so let's see what does it mean. So 0, C is 0, right? C equals 0. Now what you need to have x minus 0, right? We will first consider delta is 1. Okay, so delta is greater than, delta is should be greater than 0, so delta is equal to 1. Okay, when delta is equal to 1, x should be some value less than 1, right? X should be some value less than 1. Uh, so it's getting closer and closer to 1, right? Uh, so if you put uh, this, so magnitude of sine x over x is 1, what is the value, right? Uh, so we put maybe 1 for x, right? So we can put 1. So when you put 1, you can put sine 1 uh, minus 1. So that value is 0.15. So we can say that it is less than zero point 0.2. Okay, so it is less than zero point 0.2, less than zero point 0.2. Okay, less than zero point 0.2. And then you found that epsilon, which is which is greater than which is greater than which is greater than 0. Okay, and then you can find again some other value. 0, let's say 0.15. Just put 0.15, right? Uh, then we can see that sine x over x minus 1, we need to see whether it yields a positive value, right? So if it is less than 0.15, let's put zero point 0.1. Okay, sine zero point 0.1 divided by zero point 0.1, and then minus 1. So the magnitude is even smaller than this, right? So you found another epsilon greater than 0, right? For any delta that you pick, you find any epsilon, right? So that means this limit holds, right? Okay, so let's work on another example. Example 1. Let fx equals 8x plus 3. Prove that limit x goes to 3 f of x equal 27 using the formal definition of limit. Now, what we're going to do is to create f of x minus 27. That is f of x minus L, right? So what is f of x? F of x is 8x plus 3 minus 27. That will give us 8x minus 24. And that I can take 8 out. That will give us 8 minus 8 times x minus 3 magnitude. Uh, so what we need to prove is that uh, we want to find a delta, right? For any delta, we need to find some epsilon, right? We need to find some epsilon that is greater than 0. And if we can find something like that, then the limit exists, right? So, so this is our size of the gap. This is the gap, right? And when x goes to 3, that gap getting closer and closer, right? So, and if you consider the c is 3, right? So x minus 3, you need to find some delta, right? You need to find some delta. So if 8 times, if x minus 27 magnitude less than epsilon, then that means 8 times x minus 3 magnitude less than epsilon. That means x minus 3 magnitude less than epsilon over 8, right? What do you mean? Now, by taking delta equals epsilon 8, epsilon divided by 8, we find some delta for each epsilon that satisfy this inequality. So that means, right? That means with uh, our choice of epsilon, delta equals epsilon 8, we have proved that the limit exists. The limit exists. Okay, does that make sense? So go to example 2. F of x squared. Okay, uh, prove that limit x goes to 2, x squared equal 4, right? So we find the gap first. F of x minus 4 or minus L. In this case, it is equal to x squared minus 4. And we can write this x plus 2, x minus 2. Okay. Uh, so x in between So our requirement is that x minus 2 should be in between 0 and delta, uh, less than 1, right? Less than 1. Um, so we can assume that this delta greater than 0 but less than 1. So we can assume that x minus 2 is less than 1 in this case. Which means our x, right? Our x is, so what does that mean is x minus 2 is greater than negative 1 and less than 1, right? So that means if you add 2 into this side, this is 1, right? 1, adding 2, minus 1, 2, right? 2 minus x minus 2 plus 2 minus 1, 2, right? You have x less than greater than 1 and less than 3. So x can vary between 1 and 3. So the maximum value that x plus 2 can get is 5, right? This is 5. So this is x minus 2 times 5. Okay. So if that is less than epsilon, right? That means if we choose delta equals epsilon over 5, right? We can satisfy this. So that means you get x squared minus 4 for any epsilon greater than 0 value. Choosing delta equals epsilon over 5, you can ensure that x minus 2 less than uh, epsilon less than delta, right? Or epsilon over 5, right? So that's how you prove by using the formal definition of uh, limit. Uh, we will talk more examples in class, and that's all I have for this video. Thank you very much.